So this is problem 64 from page 274. And what happens is we're given these zeros and we're asked to write a polynomial that has these zeros. So this is basically what we've been doing on the other problems in reverse. So these are the answers. We want to get to the original question. So if if negative 2 is one of my zeros, it had to come from the factor x plus 2, right? If I plug that in, it's going to be negative 2. 0 would have come from x, or x plus 0. 2 would have come from x minus 2. And 4 would have come from x minus 4. So now here I have it in factored form. And in order to get to where it came from, I just have to multiply it out. And you can multiply it out in whatever order you want. It does get to be a little burdensome sometimes, but we'll do what we can. So I'm going to multiply these ones out first. Difference of squares, my middle term's going to drop out. My 2x and my negative 2x will drop out. So this will be, that's still an x. X times x is x squared. 2 times negative 2 is negative 4. And that's multiplied by x minus 4. And now I'm going to multiply this, multiply this part by that part. So let's see, x squared times x is x cubed. X squared times negative 4 is negative 4x squared. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. And that whole thing is still multiplied by x. So last piece, I'm going to distribute that x in there. Everything's going to get multiplied by x. So this would be x to the 4th minus 4x cubed minus 4x squared plus 16x. So that would be my polynomial. There's an infinite number of them, but this is the simplest case. Like I could multiply everything by 7, you know, it would still have the same zeros. So this is a polynomial that would have these zeros. Notice it's like everything we've been doing just in reverse. Like typically I give you this and ask you to find those, so you factor them all out to get to here. But now I give you these zeros and you multiply it on out to get down to the polynomial that has those zeros.